In this class, we are going to discuss about coal and petroleum. About coal, we have discussed earlier types of coal, destructive distillation of coal, uses. So today we will be starting with petroleum. Petroleum is nothing but the crude oil which is obtained from the deposits which are present inside the land. When it is present inside the sea, then movable platforms are used to take out the petroleum, like the one in Mumbai High. While if it is present on land, then a drilling ridge is drilled and the petroleum is taken out. The various layers which may be present are: first will be the earth's crust, then will be the shale, is nothing but the sand, then impervious rock. We can tell that the petroleum is present between the two layers of impervious rocks. Impervious rocks means which are not transferring anything, through which anything cannot be transferred. Then is the petroleum, and then is seawater. On the basis of this, we can say that petroleum is having more density or less density than seawater, because it is oil only, and we know oil has less density than water. Out is natural gas is present, which automatically comes out on drilling. Impervious rock. Now, as we know, the process of formation of coal, we call it as carbonation. The process of formation of petroleum is as follows. First, I want to discuss how it comes. When we drill the hole, then the first time the natural gas comes out very fast, and with it some petroleum also comes out. So we have to make separate openings for natural gas as well as petroleum. We make separate openings for natural gas and petroleum. Now we'll discuss about the formation of petroleum. Now, how the petroleum is formed. Petroleum is a complex mixture of several hydrocarbons, several things like kerosene, petrol, diesel, fuel oil, and many gases are present in petroleum. So we usually confuse petroleum with petrol. While petrol is obtained by the refining of petroleum. Means petrol is just a component of petroleum. Formation, we will see. Formation: the petroleum is formed from the dead organisms living in the sea. Living in the sea. From the organisms living in the sea. The remains of these organisms were deposited in the shallow depressions of the sea long ago. And they were covered by layers of sand and clay which comprised these remains. The petroleum so formed migrated from the source rock to be entrapped in large underwater reservoirs beneath impermeable rock. Petroleum often floats over a layer of water and is held in position under pressure by the pressure of natural gas. By the pressure of natural gas. refining. Then we'll discuss about the refining of petroleum. Now, what is refining? It is nothing but the separating the various impurities and components of petroleum and taking out petrol from that, and separating the petroleum into various components to be used on commercial purposes. It's called refining. As you know, the petroleum is a mixture of several hydrocarbons. It is foul smelling, brown black liquid. It cannot be used in this crude form as because it contains a lot of impurities. The process of separating various components of petroleum from one another is called refining. This is done by a process called as fractional distillation. Which is based on the fact that the different components of petroleum have strictly different boiling points. Now, this is the principle of fractional distillation. That the different components of petroleum are having different boiling points. This is what it forms the basis of the separation of various components. The components of petroleum are separated in large fractionating column. Crude oil is piped to the refinery from a well. First of all, the crude oil is washed with acid and bases because acid will remove the basic impurities, or base will remove the acidic impurities. Crude oil is now heated at about 673 Kelvin. At this temperature, all the oil melts. As the mixture of hot vapor rises up in the column, it cools. It cools. The compound with the highest boiling point condenses first and is collected. Condenses first and is collected. The compound with the low boiling point moves up and is collected above in the fractionating column. The compound with the highest boiling point condenses first and is collected. The various components contained at different heights of the column are collected separately. The components obtained at different heights in order from bottom are asphalt, lubricating oil, paraffin wax, fuel oil, diesel, kerosene, petrol, and petroleum gas. If the number of components are less, then we can use a smaller column as well. So here is a furnace in which we heat the crude petroleum. After heating at high temperatures, the crude oil is put inside below the column, the vapor rises up in the column and keeps condensing at different boiling points. The component which is achieving its boiling point at a particular height will be deposited there, and we tap out the various components at different places. And this is the separation of the phase of distillation. We call it as fractional distillation. So we tell that the various components of petroleum are separated by the process of fractional distillation. This is the diagram of petroleum. This is just to show that at lower boiling points, lower fractions are obtained. At higher boiling points, higher fractions are obtained. Above, the lower fractions are obtained, having low boiling point, lower boiling point. Example, petrol. It is having a boiling point of 340 to 393 Kelvin. It is obtained above the column, above. Then it's kerosene. Then it's kerosene. It is obtained the boiling range of 423 73 Kelvin. Then is diesel oil. It is having obtained from the boiling range of 473 623 Kelvin. Then is fuel oil. Obtained is a boiling range of 473 623 Kelvin. So various components which are obtained from the fractional distillation of petroleum are residual oil. It is obtained from primary distilled petroleum and is reduced. Bitumen is largely used in making. It is distilled in vacuum to yield bitumen. Bitumen is largely used in making road surfaces. The next component obtained is the paraffin wax. Nothing but the wax. It boils at about 673 Kelvin. Is used for making candles, ointments, grease, polishes. Etc. Next is the lubricating oil. The boiling range is 623 to 673 Kelvin. 73 Kelvin. It is obtained fractionation of gasoil. Next, the fuel oil. Its boiling range is 573 to 623 Kelvin. It is a better fuel than coal but completely burns, leaving behind no ash, whereas coal burns producing a large amount of ash which has to be removed regularly. Then is the diesel oil. Its boiling range is 573 to 623 Kelvin. It is obtained and used in cars, diesel car. Then is the kerosene. The boiling range of 423 to 573 Kelvin. It is used in lanterns, lamps, stores, etc. Next component is petrol. Its boiling range of 343 to 393 Kelvin. It is used in cars, buses, and all the vehicles for driving purpose, for the transportation purpose, used widely. Then is the petroleum gas. It is a mixture of ethane, propane, and butane. Butane can be easily liquefied under pressure. And it's commonly, butane is liquefied under high pressure, and the liquid form is supplied as cylinders. which commonly called as LPG, that is liquefied petroleum gas. So, and liquefied petroleum gas does not have any characteristic smell of its own. An external chemical known as this ethyl mercaptan is added, which supplies smell to it, so that its leakage can be detected. This is added externally for the smell. Any accidental leakage can cause an explosion. If there is any leakage of gas from the cylinder, the following precautions should be immediately taken. Some precautions which we should do on leakage detection, they are: no open flame should be kept as such. All doors and windows should be open. The tube joints attached to the cylinder should be systematically checked for defects. And IPCL is the Indian Petrochemical Corporation Limited in Vadodara, is one of the largest petrochemical units in the world. In the next lecture, we'll discuss about the natural gas, which is the third component of it.